In the vast expanse of the Atlantic Ocean in 1492, picture yourself standing on the creaking wooden deck of a small caravel. The salty breeze whips against your face as you gaze at the endless horizon where sea meets sky. You are hundreds of miles from any known land, surrounded by nothing but rolling waves and the haunting calls of distant seabirds. Your life and the lives of your entire crew depend entirely on a handful of primitive instruments and the raw courage of men who dared to venture into the unknown. The wooden vessel beneath your feet is your only sanctuary in this marine wilderness. Each creak of the timber, each splash of waves against the hull reminds you of your vulnerability in this vast liquid desert. Your most sophisticated navigation tools would seem laughably simple by today's standards. A brass astrolabe, a wooden quadrant, and a collection of hand-drawn charts. Yet these basic instruments were the difference between finding your way home and being forever lost in the trackless sea. Consider this. With no radio communication, no GPS, no modern weather forecasting, and no satellite imagery, how did these brave sailors navigate through thousands of miles of uncharted waters? They relied on the same stars that had guided their ancestors, but with innovative tools that transformed celestial observation into practical navigation. During the day, they tracked the sun's position. At night, the stars became their silent guides. Every calculation was a matter of life and death. Every decision could mean the difference between discovery and disaster. These mariners weren't just sailors. They were mathematicians, astronomers, and adventurers rolled into one. They could read the ocean's moods in the changing colors of the water, predict storms from the patterns of clouds, and calculate their position using nothing more than the angle of the sun and basic trigonometry. Their instruments might appear primitive to our modern eyes, but in skilled hands they were sophisticated enough to guide ships across thousands of miles of open ocean with remarkable accuracy. This was the reality of oceanic exploration in the age of discovery, a delicate balance between human ingenuity and nature's might, where survival depended on the careful marriage of courage and calculation. These intrepid explorers didn't just sail into the unknown. They revolutionized our understanding of navigation and laid the groundwork for the global civilization we know today. From Vasco da Gama's navigation diary of 1497 comes one of history's most poignant reflections. Each league sailed was a challenge against the unknown, every nautical mile a battle against geographical ignorance. These words, penned during humanity's greatest era of maritime exploration, capture the essence of an age when brave men ventured into uncharted waters, armed with nothing but primitive instruments and an unwavering determination to push beyond the boundaries of the known world. Consider the magnitude of what these words truly represent. In 1497, when Vasco da Gama embarked on his historic voyage to India, the world was still largely a mystery. The Atlantic Ocean was considered the edge of civilization, and what lay beyond the Cape of Good Hope was the subject of terrifying legends and maritime myths. Each day at sea brought new challenges that tested not only the crew's courage, but also their faith in the rudimentary navigation tools that guided them. This wasn't merely a journey across water, it was humanity's first real step into globalization. Every nautical mile covered by da Gama's fleet represented a victory over centuries of geographical misconceptions. The Portuguese navigator's words reflect the immense psychological burden of sailing into waters where European ships had never ventured before. Each sunrise brought new questions. Would their calculations prove accurate? Would their maps, drawn from second-hand accounts and ancient texts, bear any resemblance to reality? Da Gama's diary entry encapsulates a pivotal moment in human history when mariners transformed from coastal sailors into true oceanic explorers. They were no longer simply following coastlines or familiar trade routes. They were carving new paths across vast, empty oceans. Their success would revolutionize not just navigation, but also commerce, cultural exchange, and humanity's understanding of our world. The stakes were unprecedented. Every league sailed represented not just distance covered, but also the expansion of human knowledge. Each successful calculation of position using an astrolabe or quadrant was a small victory over the unknown. These men were not just sailing ships. They were slowly, methodically pushing back the boundaries of human ignorance about our planet. This moment in history marked the beginning of what we now call the modern age, an era when humanity finally began to understand the true scale and nature of our world. The achievements of these navigators would lay the foundation for today's interconnected global civilization. Want to discover how this moment changed the course of history forever? Hit the bell, like and subscribe to Modern Age Chronicles to embark on this unique journey through the modern age. Bartolomeu Dias stands as one of history's most remarkable navigators, a Portuguese explorer whose mastery of seemingly mystical instruments would forever change maritime history. In 1488, armed with an astrolabe of brass and a quadrant of wood, Dias accomplished what many thought impossible. His journey around the southern tip of Africa wasn't merely a voyage. It was a testament to human ingenuity and the power of primitive yet effective navigation tools. Imagine Dias on the deck of his caravel, holding his astrolabe steady despite the rolling waves, squinting at the sun through its sights. This man, who had learned his craft through years of experience, could determine his ship's position with remarkable accuracy, using what we would now consider the most basic of tools. His understanding of these instruments was so profound that he could read the stars and sun like modern sailors read GPS coordinates. The way Dias used these instruments bordered on artistry. In an age when most believed sea monsters lurked beyond the horizon, he transformed mathematical calculations into safe passages. His success in rounding the Cape of Good Hope wasn't luck. It was the result of meticulous observation, careful calculations, and an almost supernatural ability to interpret the data his instruments provided. Then there's Christopher Columbus, a man whose relationship with navigation tools verged on obsession. Unlike many of his contemporaries, Columbus wasn't content to simply use these instruments. He studied them, improved upon them, and pushed them to their limits. His personal copies of navigation charts were filled with detailed notes and calculations, reflecting countless hours spent perfecting his understanding of maritime mathematics. Columbus's genius lay in his ability to combine different tools and techniques. He would cross-reference his quadrant readings with dead reckoning calculations, consult his charts while considering ocean current patterns, and maintain detailed logs of every observation. His ships carried multiple versions of each instrument, not out of excess, but because he understood that even the smallest measurement error could mean the difference between discovery and disaster. What made Columbus truly remarkable was his ability to adapt these instruments to entirely new challenges. While most navigators of his time used their tools for familiar Mediterranean routes, Columbus dared to apply them to transatlantic navigation. He developed new methods for using the astrolabe in the southern hemisphere, where familiar stars disappeared below the horizon and new ones took their place. These men weren't just users of technology, they were innovators who pushed the boundaries of what their instruments could achieve. Their legacy lies not just in the lands they discovered, but in how they transformed simple tools into keys that unlocked the world's greatest mysteries. They proved that with enough skill and determination, even the most basic instruments could guide ships across thousands of miles of open ocean. Their stories remind us that technology is only as good as the people who use it. In their hands, simple devices of wood and brass became instruments of discovery that changed the course of human history. They were not just navigators, they were pioneers who bridged the gap between medieval navigation and the dawn of modern maritime exploration. Life aboard a 15th century sailing vessel was an assault on all senses. The pervasive smell of wet wood permeated every corner of the ship, mixing with the pungent odor of tar used to seal the wooden planks. This protective coating created a distinctive aroma that became synonymous with seafaring life, a scent that would cling to sailors' clothing for months after returning to land. The constant dampness was inescapable. Sailors wore thick woolen garments that, while uncomfortable in warmer climates, were essential for survival. These heavy clothes would remain wet for days, sometimes weeks, creating a perpetual state of discomfort. The wool, however, retained its warming properties even when soaked, making it an invaluable defense against the harsh Atlantic winds and sudden squalls. The ship itself was a symphony of maritime sounds. The constant creaking of timber as the vessel fought against the waves created an ever-present backdrop. Overhead, the hemp ropes strained and groaned under the pressure of wind-filled sails. The canvas sheets themselves produced a thunderous flapping when caught by strong gusts, while the blocks and tackles rattled rhythmically with each wave. During storms, these familiar sounds would transform into a cacophony of violent crashes and snaps that tested both the ship's structure and the crew's nerves. Below deck, navigators hunched over their delicate instruments in cramped quarters, attempting complex calculations while battling seasickness and exhaustion. These skilled men worked by dim lamplight that swayed precariously with the ship's motion, making their precise measurements even more challenging. Their workspace was often no larger than a modern closet, yet here they plotted courses that would guide vessels across thousands of miles of open ocean. The daily routine was dictated by the ship's bell, marking time in 4-hour watches. The limited space meant that sailors slept in shifts, their hammocks swinging in unison with the ship's roll. The galley fire was one of the few sources of warmth, though it could only be lit in calm seas. Here, the cook prepared simple meals of salted meat, hardtack, and dried peas, a monotonous diet that reflected the severe limitations of food preservation in the age of exploration. At night, the darkness was absolute, save for the navigation lanterns and the stars above. The phosphorescent wake of the ship created ghostly patterns in the water, while the wind in the rigging produced an eerie whistling that sailors came to associate with voices from the deep. These conditions, combined with the isolation of ocean travel, gave rise to countless maritime superstitions and tales that became an integral part of seafaring culture. This was the harsh reality of life for those who dared to venture into unknown waters, armed with nothing but primitive instruments and an unwavering determination to push beyond the boundaries of the known world. Their everyday existence was a constant battle against the elements, where survival depended on the delicate balance between human ingenuity and nature's raw power. In the age of maritime exploration, 3 remarkable instruments revolutionized navigation and transformed humanity's ability to traverse the vast oceans. These tools, though primitive by today's standards, represented the pinnacle of medieval technology and human ingenuity. The Astrolabe stood as the most sophisticated navigational instrument of its time. This intricate brass disc, typically ranging from 6 to 8 inches in diameter, was a masterpiece of medieval engineering. Each instrument was carefully graduated with precise angular measurements, often down to fractions of a degree, and featured an intricate network of circles representing celestial coordinates. At its heart, the Astrolabe was a complex analog computer. Its face contained multiple rotating components: the reta, which mapped major stars, the rule used for measurements, and the mater, which held altitude scales. The instrument's design allowed navigators to solve complex astronomical problems and determine their position with remarkable accuracy for the time. The process of using an astrolabe required considerable skill. Navigators would hold the instrument vertically, sight the sun or stars through its alignment pins, and read the angle indicated on the graduated scale. This measurement, combined with astronomical tables and mathematical calculations, allowed them to determine their latitude with an accuracy often within 1 degree, an extraordinary achievement for the 15th century. The quadrant, despite its relative simplicity, was an indispensable tool in the navigator's arsenal. This quarter-circle instrument, typically crafted from hardwood and brass, combined mathematical precision with practical durability. Its design featured a 90-degree arc divided into degree measurements, with a plumb bob suspended from its apex to ensure vertical alignment. What made the quadrant particularly valuable was its versatility in varying weather conditions. While the Astrolabe struggled in rough seas, the quadrant's simpler design and plumb bob system allowed for more stable measurements. Navigators would sight celestial bodies along the quadrant's straight edge, while the plumb line indicated the angle on the graduated arc. The margin for error was incredibly small. A measurement error of just 2 degrees could throw a ship off course by over 120 nautical miles, potentially the difference between reaching a safe harbor and becoming lost at sea. This reality required navigators to develop extraordinary skill and patience, often taking multiple measurements to ensure accuracy. The nautical charts of the Age of Discovery represented a revolutionary fusion of art, science, and imagination. These meticulously crafted documents were drawn on vellum or parchment, materials chosen for their durability in marine conditions. The most sophisticated charts were products of the famous cartography schools, such as Portugal's Sagres school, where generations of knowledge were compiled and refined. These charts were remarkable achievements of information synthesis. Cartographers integrated data from multiple sources: astronomical observations, sailors' accounts, ancient texts, and mathematical calculations. They developed sophisticated systems for representing ocean currents, prevailing winds, and dangerous reefs, often using elaborate color coding and symbolic representations. The Portolan charts, as they were known, featured an innovative system of rhumb lines, straight lines showing compass directions that could be followed with a constant bearing. These lines, intersecting at compass roses placed strategically across the chart, allowed navigators to plot courses across vast distances with unprecedented accuracy. Perhaps most remarkably, many of these charts were created by cartographers who had never seen the places they mapped. They relied on sailors' descriptions, astronomical calculations, and careful measurement of sailing times between known points. This led to a fascinating blend of accurate geographical information and speculative details, often including elaborate illustrations of sea monsters and mythical islands. The charts also contained vital, practical information that couldn't be mathematically calculated. The color of coastal waters, indicating depth, the presence of safe harbors, and locations of fresh water sources. This information, passed down through generations of sailors, was often as valuable as the geographical coordinates themselves. Together, these 3 instruments formed an integrated navigation system that made long-distance ocean travel possible. Their use required not only technical skill, but also a deep understanding of astronomy, mathematics, and natural phenomena. These tools transformed the art of navigation from coastal piloting to true oceanic wayfinding, enabling the great voyages of discovery that would reshape human understanding of our world. The remarkable achievements of maritime exploration during the Age of Discovery are meticulously documented through a rich collection of historical artifacts and written records that survive to this day. These precious pieces of history provide invaluable insights into the technical sophistication and daily challenges of medieval navigation. The original navigation journals represent some of our most valuable windows into the Age of Discovery. Columbus's logbook, though only surviving in abstract form through Bartolomé de las Casas's transcription, provides detailed accounts of astronomical observations, weather patterns, and navigational calculations. Each entry reveals the methodical nature of medieval navigation and the constant battle against uncertainty. Vasco da Gama's route journal from his 1497-1499 voyage to India stands as one of the most complete surviving navigation documents. Its pages contain precise latitude measurements, detailed descriptions of coastlines, and careful notes about ocean currents. The journal also includes fascinating observations about local cultures encountered during the voyage, making it both a technical manual and an anthropological record. Perhaps most remarkably, these logs reveal the evolution of navigation techniques. Entries often show corrections to earlier calculations, demonstrations of new methods, and adaptations to unexpected challenges. Margin notes frequently contain astronomical tables and mathematical calculations, showing how theory was put into practical application at sea. European museums house an extraordinary collection of preserved astrolabes, each telling its own story of maritime innovation. The British Museum's collection includes the earliest known maritime astrolabe, dated to 1496, recovered from a Portuguese shipwreck. This instrument bears the marks of countless measurements, its brass surface worn smooth in places from years of handling by skilled navigators. The Maritime Museum in Lisbon holds what many consider the finest collection of naval astrolabes in the world. These instruments show the evolution of design from complex astronomical devices to simplified maritime versions specifically adapted for use at sea. The graduated scales on these instruments still bear their original markings, allowing modern scholars to assess their remarkable accuracy. The Victoria and Albert Museum in London houses several astrolabes that show evidence of customization by their users. These modifications, additional sight holes, reinforced mounting points, and added reference marks provide insight into how individual navigators adapted their instruments to meet specific challenges. The charts produced by Portugal's famous School of Sagres represent the pinnacle of medieval cartographic achievement. These documents, preserved in various Portuguese archives and museums, demonstrate an extraordinary synthesis of theoretical knowledge and practical experience. The most famous surviving charts show the gradual expansion of European geographical knowledge. Early maps of the African coast reveal increasingly accurate coastlines as more voyages were completed. The charts also contain invaluable annotations about safe harbors, dangerous reefs, and optimal sailing routes, information that was literally worth its weight in gold during the age of exploration. The Sagres charts are particularly notable for their innovative technical features. They introduced new methods for representing wind patterns and ocean currents, using an intricate system of symbols that would influence maritime cartography for centuries. The charts also feature sophisticated distance scales that accounted for the curvature of the Earth, a remarkable achievement for their time. Marine archaeology has provided crucial physical evidence that complements written records. The discovery of navigation instruments aboard shipwrecks has allowed historians to verify the accuracy of contemporary descriptions and understand how these tools were actually used at sea. The instruments found in shipwrecks often show signs of modifications and repairs, indicating how sailors adapted their tools to meet real-world challenges. The combined documentary evidence from ships' logs, preserved instruments and charts reveals a sophisticated understanding of navigation that challenges our preconceptions about medieval technology. These materials show that successful navigation relied not just on instruments and charts, but on a complex system of knowledge passed down through generations of sailors and refined through practical experience. Contemporary scientists and historians continue to study these artifacts using advanced technology. Recent analysis of preserved astrolabes using 3D scanning has revealed previously unknown details about their construction and use. Similar studies of nautical charts have uncovered hidden information in their construction lines and mathematical frameworks. This rich collection of physical evidence and documentation continues to provide new insights into one of humanity's most remarkable achievements, the mastery of oceanic navigation using tools that, while primitive by today's standards, represented the cutting edge of medieval technology and human ingenuity. The development and mastery of medieval navigation instruments catalyzed changes that extended far beyond maritime technology, fundamentally reshaping human civilization in ways that continue to resonate today. This technological revolution triggered a cascade of transformations across multiple spheres of human activity and understanding. The reliable navigation instruments of the Age of Discovery enabled the first truly global trading networks. This transformation went far beyond simply connecting existing markets. It created entirely new economic paradigms. Portuguese spice traders could now reliably navigate to India, eliminating the need for numerous middlemen along traditional land routes. Spanish galleons established regular trans-Pacific trade routes, creating the first direct commercial links between Asia and the Americas. This newfound navigational capability led to the establishment of the first multinational trading companies, such as the Dutch East India Company and the British East India Company. These organizations, made possible by reliable ocean navigation, became the world's first global corporations, pioneering many business practices we still use today. The precision offered by these instruments also revolutionized maritime insurance and trade financing. Investors could more accurately predict voyage times and risks, leading to the development of sophisticated financial instruments and the birth of modern banking practices in trading centers like Amsterdam and London. The ability to navigate accurately across oceans triggered unprecedented levels of cultural exchange. For the first time in human history, sustained contact between vastly different civilizations became possible. This led to the Columbian Exchange, the massive transfer of plants, animals, culture, technology, and diseases between the old and new worlds, language evolution, the development of pidgin languages and trade languages that facilitated international commerce, culinary revolution, the global distribution of crops and cooking techniques that transformed diets worldwide, artistic cross-pollination, new artistic styles emerging from the fusion of different cultural traditions. The implementation of these navigation instruments fundamentally altered humanity's conception of geography. The ability to accurately measure latitude and maintain precise courses led to the first accurate world maps, the discovery that the world was significantly larger than previously calculated, the refutation of many medieval geographic myths, the development of standardized geographic coordinates, the creation of the first scientific approach to cartography. These advances in geographic knowledge had profound philosophical implications, forcing European scholars to reconsider their place in the world and their relationships with other civilizations. Perhaps the most profound impact was on human consciousness itself. The ability to navigate globally led to the concept of a truly interconnected world, the recognition of the Earth as a single navigable sphere, the development of universal time standards, the emergence of global perspectives in politics and commerce. The success of navigation instruments contributed significantly to the scientific revolution by demonstrating the practical value of mathematical precision, providing empirical proof of astronomical theories, encouraging the development of more precise measuring instruments, fostering a mindset that valued observation and measurement over tradition. The mastery of oceanic navigation reshaped global power structures, enabled the creation of the first truly global empires, revolutionized naval warfare strategies, led to the development of specialized military vessels, shifted the center of global power from land-based to maritime nations. The demands of oceanic navigation created new educational and professional paradigms. Establishment of specialized navigation schools, development of standardized training for navigators, creation of new professional classes of cartographers and instrument makers, integration of mathematics and astronomy into practical education. The ability to navigate globally led to the first comprehensive understanding of ocean currents and wind patterns, global weather systems, marine ecosystems, climate variations across latitudes. The impact of these revolutionary instruments continues to influence modern developments. Modern GPS systems follow principles first established by medieval navigators. Global trade routes established during this period remain important today. International maritime laws and conventions trace their origins to this era. Modern navigation technology builds upon these fundamental concepts. The revolutionary navigation instruments of the Age of Discovery did more than enable safer ocean travel. They fundamentally altered human civilization's understanding of itself and its world. Their impact extended into every aspect of human activity, from commerce to culture, from science to philosophy, creating the foundation for our modern globalized world. The Age of Discovery emerged during one of humanity's most transformative periods, when medieval thought was giving way to revolutionary new perspectives. The scientific Renaissance transformed Europe from a realm of mysticism and superstition into a crucible of empirical observation and methodical inquiry. This intellectual revolution provided the foundation that made sophisticated oceanic navigation possible. The scientific Renaissance marked a fundamental shift in how humans approached knowledge. Instead of relying solely on ancient texts and established authorities, scholars began to emphasize direct observation and experimentation. This new methodology proved crucial for navigation, as sailors needed to accurately measure and record their observations to traverse vast oceans successfully. The development of precise astronomical tables and mathematical formulae grew directly from this empirical approach to understanding the natural world. Humanist philosophy played an equally vital role in enabling the age of exploration. By placing human achievement and potential at the center of intellectual discourse, humanism encouraged the bold thinking necessary for oceanic ventures. The humanist emphasis on human capability and individual achievement helped break down medieval fears about venturing into unknown waters. This philosophical shift empowered navigators to trust their observations and calculations rather than relying on superstition and folklore. Mathematics and astronomy underwent unprecedented advancement during this period. The recovery and translation of ancient Greek mathematical texts, combined with innovations from Arab scholars, provided navigators with sophisticated tools for calculating position and plotting courses. Astronomical understanding progressed rapidly as well, with more accurate models of celestial motion enabling better navigation tables. The practical demands of navigation actually drove many of these advances, as sailors required ever more precise mathematical and astronomical knowledge to venture further from familiar shores. The breaking of medieval paradigms proved crucial for the advancement of navigation. Traditional geographic concepts, often based on religious rather than empirical foundations, gave way to more accurate understandings of the world's structure. The medieval belief in a flat Earth surrounded by mysterious waters was replaced by clear evidence of a spherical planet with navigable oceans. Similarly, the notion that certain regions were inherently impassable due to divine decree yielded to the understanding that proper navigation techniques could take ships virtually anywhere. This period witnessed the emergence of new educational institutions dedicated to practical knowledge rather than purely theological study. Navigation schools, such as Portugal's famous Sagres School, combined theoretical knowledge with practical experience in unprecedented ways. These institutions broke down the traditional barriers between scholarly learning and practical application, creating a new class of educated navigators who could both calculate complex astronomical positions and handle a ship in heavy seas. The revolution in timekeeping during this period proved especially significant for navigation. Medieval concepts of time, often based on church bells and solar positions, gave way to more precise mechanical measurements. This advancement proved crucial for navigation, as accurate timekeeping was essential for calculating longitude and maintaining precise ship's logs. Perhaps most significantly, this period saw the emergence of what we might call the first scientific worldview. The success of navigation using mathematical and astronomical calculations demonstrated that the natural world operated according to comprehensible, predictable principles. This understanding laid the groundwork for the later scientific revolution and our modern technological civilization. The interaction between theoretical knowledge and practical application during this period created a virtuous cycle of advancement. Theoretical breakthroughs improved navigation capabilities, while the practical demands of navigation spurred further theoretical developments. This dynamic relationship between theory and practice became a model for technological development that continues to influence innovation today. The civilizational context of the Age of Discovery thus represents far more than just technological advancement. It marks a fundamental shift in how humans understood their world and their capability to comprehend and master it. The navigation instruments developed during this period were both products and catalysts of this broader intellectual revolution, tools that simultaneously reflected and advanced humanity's expanding horizons. Did you know that the margin between success and disaster in medieval navigation often came down to the smallest of measurements? The extraordinary precision required in using navigation instruments reveals both the sophistication and the terrifying stakes of early ocean exploration. Let me share some remarkable facts that showcase the incredible precision and skill of medieval navigators. Consider this. A mere half-degree error when measuring with an astrolabe could send a ship hundreds of kilometers off course. To put this in perspective, that's about the width of your thumb at arm's length against the horizon. Such a tiny error, accumulated over thousands of miles of ocean sailing, could mean the difference between reaching a safe harbor and becoming hopelessly lost at sea. This demonstrates the extraordinary skill required of medieval navigators, who had to take these measurements on rolling ship decks, often in challenging weather conditions. Even more fascinating is the fact that many of history's most accomplished navigators were technically illiterate, unable to read or write, yet could perform complex astronomical calculations with remarkable accuracy. These sailors developed sophisticated mental mathematics skills, memorizing vast arrays of astronomical tables and geometric principles. They could calculate a ship's position using nothing but the stars, basic instruments, and their well-trained minds. This challenges our modern assumptions about education and expertise, showing how practical knowledge could triumph over formal learning. These navigators developed their own specialized forms of knowledge transmission. Unable to rely on written manuals, they passed their skills from master to apprentice through hands-on training and oral tradition. They created memory techniques and practical methods that allowed them to perform complex calculations without writing anything down. Some could recite entire astronomical tables from memory, tables that in printed form would fill dozens of pages. Here's another surprising fact. Medieval navigation instruments were so precise that modern replicas, when tested using period techniques, can achieve accuracy within 1 to 2 nautical miles, comparable to early electronic navigation systems. This remarkable precision was achieved using instruments made of wood and brass, operated entirely by hand, with calculations done entirely in the navigator's head. The next time you glance at your GPS device, Remember that you're holding the technological descendant of these remarkable medieval instruments. While modern satellite navigation can pinpoint our location within a few meters, it operates on many of the same principles developed by those early navigators. They too were calculating position based on celestial observations and mathematical principles. They just did it with far simpler tools and an extraordinary degree of skill. Want to discover more secrets of the great age of exploration? Join us at Modern Age Chronicles, where we uncover the fascinating stories behind humanity's greatest adventures. From the mathematical genius of illiterate sailors to the precision engineering of medieval instruments, we explore how these remarkable innovations transformed our world. Subscribe now to embark on an extraordinary journey through history's most exciting era of discovery. Remember, every modern navigation technology, from the simplest compass app to the most sophisticated GPS system, traces its heritage back to these brilliant medieval innovators. Subscribe to Modern Age Chronicles now to continue this fascinating journey through the history of human ingenuity and exploration. Let's uncover together how these remarkable achievements of the past shaped our present and continue to influence our future.